Hello everyone, welcome to the RCNP course. And this part, we're going to introduce the RLDP principle. And firstly, let's take an overview of this protocol. RLDP, which stands for Rapid Link Detection Protocol, and is developed by Ruijie for rapidly detecting Ethernet link failures. General Ethernet link detection mechanism detect link connectivity based on physical connection status and automatic negotiation at the physical layer. Such mechanisms have limitations and cannot provide users with reliable link detection information in specific scenarios. For example, the first scenario is that among the optical fiber of port SB1, the core receiving signal pairs while the core transmitting signal is normal. As a fiber converts exists, the peer device displays normal TX and RX. And the second scenario is that an ISP transmission network exists between two Ethernet devices. If the network fails, the Ethernet devices at both ends cannot sense the failure in the network. So in this case, what we can use is the RLDP. So let's see the principle. RLDP defines two kinds of protocol packets, probe packet and equal packet, which destination address is layer 2 multicast address. Each port with RLDP config and in link up state periodically send its probe packets and wait for the adjacent ports to respond to this packet. It also expects probe packets from adjacent ports. If a link is normal both physically and logically, the port should be able to receive an equal packet and a probe packet from the adjacent ports. Otherwise, the link is considered abnormal. And Ruijie RLDP provides three functions. First is the loop detection and the one-way link detection and both-way link detection. So about these three functions, let's see the first one first. RLDP is mainly used on access layer switches for loop detection and is especially applicable to detect of self-loop of a downlink hub of a switch, which cannot be prevented by STP. So here you should know that normally in the switch network, we prefer to use STP to prevent loops. Right? For example, we have multiple switches and there are some layer 2 loops exist. So by using no matter STP or RSTP or MSTP, we can figure out the loop and block some of the ports to solve the problem caused by loops. But some of the loops in the switch network cannot be prevented by STP. For example, as you can see here, if I use a cable to connect two local interfaces on an access switch, or you can see an access switch is connected with the hub, and I use a cable to connect two local ports on this hub. So in this way, we can use RLDP to detect the loop in these scenarios and to prevent the loop. Here it says that it's recommended that RLDP be enabled for access switch ports connecting to end users in the project implementation path. The optimized configuration that is deployed in advance can prevent loop on the ports. RLDP loop detection mainly applies to the following two scenarios as we have introduced. And then let's see how does detect the loops in these scenarios. If a port of a switch configured with RLDP receives an RLDP packet of the switch itself, here you should think about it. We said that the ports which have enabled RLDP will periodically send the RLDP packet. And if it can receive the RLDP packet of the switch itself, means there is a path from this port to the another port of on the same switch, means it's a loop, right? So here it says a loop occurs on these ports. So in this case, RLDP processes the fault according to the user configuration, including generating an alarm set the port in aerial disabled states, or disabling the port SVI, disabling port learning and forwarding. So here are some optional actions we can take to a port which have a loop. It depends on how you configure it by using the command you can see in the figure. RLDP port loop detect, block or shut down port, shut down SVI or warning. Okay, and next is about the one-way link detection. If a one-way link failure occurs, the port link can only receive or send packets, which can be caused by, for example, incorrect connection of optical fiber. As shown in the figure below, if an RLDP port receives only a probe packet, you can see the probe packet is packets sent by the adjacent port. So, but it cannot receive the response from the peer. Means this is a one-way link failure because no response represents that the peer device didn't receive the probe packet from this end. Right? I think you can understand this, right? So in this case, RLDP processes the port according to the user configuration. And the user configuration is as we have just introduced. We can block the port, we can block the SVI, or we can send an alarm. And the next is the two-way link failure. Two-way link failure is quite easy to understand. If I cannot receive the probe packet and the echo packet from a neighbor, it's a two-way link failure. Two-way means receive and forward, right? I cannot successfully receive and forward the packets from a peer. It's a two-way link failure. Okay, so about the RLDP, here are some notes you should know. The routed ports do not support the processing method of shutdown SVI. Therefore, the method can be configured but will not be executed if a failure is detected on a routed port. And when loop detection is configured, neighbor devices downlink to a port cannot enable RLDP detection. Otherwise, detection on the port will be incorrect. If RLDP detects a link failure, a warning is generated. You can configure log server to record at least 3 levels of device logs. Due to different product failures, blocked ports of certain products still send packets to the CPU because we just blocked the packet, but the state of this port is still up. So as a result, if a loop is detected on a port and the processing method is configured as block, ports still transmit a large number of packets to CPU. It will increase the utilization of the CPU and does not achieve the effect of loop detection. So therefore, it's recommended that the shutdown port processing methods be configured for loop detection. In RLDP port processing, the block function and STP are mutually exclusive. If the full processing method of a port is configured as block, it's recommended that STP be disabled. Otherwise, if a one-way link failure occurs, which cannot be detected by STP, may allow port forward while RLDP blocks. So to enable RLDP and STP at the same time, you are advised to configure the fourth processing method as shutdown port. Okay, because once we shut down the port, no matter STP or RLDP, they will not work anymore on this port. Okay, after knowing the working principle of RLDP, next let's see the configuration. Here is a typical application scenario of RLDP. As shown in this figure, users from various departments of an enterprise access the network through switch A and B. Network loops occur from time to time due to network exceptions caused by quality issues of optical fibers interconnecting devices or due to incorrect operations of users. RLDP loop detection and one-way, two-way link detection functions need to be configured to rapidly locate failures and recover the networking time. Here are the main requirements. If a one-way or two-way failure is detected on the link between switch A and B, shut down the port. If a port is detected on a downlink port of switch A and B, block the port. Recover a port 5 minutes after it is set in error disabled state. Detect all ports that failed the RLDP detection again. Okay. After knowing the requirements, next let's see the configuration of these devices. Firstly, globally enable RLDP on switch A and B by using command RLDP enable. And on the port interconnecting switch A and B, enable one-way and two-way link detection. Set the violating action to shut down ports. You can see the configuration on switch A. Int gigabit Ethernet 024 RLDP port bidirection detect shutdown port. RLDP port unidirection detect shutdown port. So we have enabled both one-way and two-way detection. And for both of them, the action is shutdown port. Then on the downlink port of switch A and switch B, enable loop detection. The action we should use is block. So for all the down ports, RLDP port loop detects block. Okay. And the next, globally configure the violation recovery action. Error disable recovery interval 300 means that after being set down to error disable states, the status will recover in about 5 minutes. Okay. And next, this is the basic configuration of RLDP. And except that we can set down parameters. For example, configure the RLDP detection interval, and the value is 3 seconds by default, ranges from 2 seconds to 15 seconds. By user command RLDP detect interval, followed with the specific value, you can change it. Configure the maximum times of RLDP detections. If a port enabling RLDP fails to receive packets from a neighbor within the maximum detection period, a failure is considered. The command is RLDP detect max, and the value ranges from 2 to 10. And to restore the port RLDP status, you can use the command RLDP reset, right, to strictly restore the port status. Okay, this is about the configuration of RLDP. And about this protocol, we should know that it can detect a one-way link failure, two-way link failure, and the loop on a switch port. Enable different actions for detected failures. About the RLDP, here are questions. After the shutdown port function takes effect, following configurations can be used to restore RLDP detection. A, RLDP reset. B, RLDP reset, but in different configuration view. C, error disable recovery interval 300. D, no shutdown. Okay, here we choose A, B, and C. Okay, D does not take effect. Okay, so that's all for this part. Thanks for your listening.